In this video, we will talk about congruences. So in the last video, we introduced this notation, A mod m, which represented the unique remainder when A is divided by m. So when you divide A by m, there's a remainder, exactly one remainder, and that's what we denote using A mod m. So just to review this, if I look at 25 mod 6, that means when I divide 25 by 6, what's the remainder? So we might even be able to see this in our heads. It's just 1. Writing out why, well, 25, if I think about the number 6, it goes into 25 4 times. That gives me 24. But then I still got to add 1 to get to 25. So 1 is the remainder. If I did the same thing with 7 mod 6, well, I can multiply 6 by 1. And then, well, to get to 7, I still got to add 1. Okay, and when I do that, I get to 7. So even with 7 mod 6, that remainder will also just be 1. Okay, so now I want to introduce some new notation. So because 25 and 7 both have the same remainder when we divide them by 6, the way I notate that is we say 25 is congruent to, and I write this 3-lined equal sign for congruent, and then I write the other integer 7. And this just means 25 and 7 have the same remainder when they're divided by 6. Or another equivalent way to say that is, if I took these two equations, I noticed that if I were to subtract them, what I get is 25 minus 7 on one side. On the other side, I'll get 6, and then I can factor out the 6 and get times 4 minus 1, and then the 1s will cancel. So what that means is, well, 25 minus 7 ends up being 6 times some integer. In other words, 6 is evenly dividing 25 minus 7. Okay, so now we're ready to state the general definition. So let A and B be integers, and let m be a positive integer. We write A is congruent to B, and then in parentheses we write mod m, if m divides A minus B. So when that happens, that's the same thing as saying that the numbers A and B have the same remainder. They have the same remainder when they are divided by m. All right, so let's practice this notation. So I want to verify if the following congruences hold. Part A says 7 is congruent to 25 mod 6. Hopefully this should check out because I have something very similar written up here. I'm just switching the order of these numbers. So to check that, I check this condition in the definition. So will 6 divide? And then I do A minus B. So the A is 7, the B is 25. So is this true? So I get 6, does it divide negative 18? And yeah, that's true. 6 does divide negative 18 evenly because negative 18 is 6 times 3. So the fact that I can do that, and this is an integer, the fact that this is an integer means that's true. 6 does divide negative 18. Okay, if I tried the same thing for this one, is 14 congruent to negative 2 mod 6? Well, I'll check, will 6 evenly divide 14, let's go to draw mode. 14 minus negative 2. So does 6 divide 16? But the answer to that is no. 6 does not divide negative 16. I'll put a slash through that divisibility symbol. So as a result, we'd say 14 is not congruent to negative 2 mod 6. Okay, so we have two different notations here. In the last video, we saw this notation A mod m. And what that means is, well, that's just the remainder. The remainder when I divide A by m. On the other hand, if I write this, A is congruent to B mod m. What that means is that A and B have the same remainder when divided by m. So this is something that we want to be careful about when we use this notation going forward.